Hey there! Let's talk about absolute value equations. So the absolute value of a number can be written with two bars. So let's say we have bar, x bar. X can represent any number you want. Let's say x was 3. So absolute value of 3 would be the distance away from 0. So in any term, you would call 3, 3. What about absolute value of negative 3? You can't say it has a negative distance. So what we do is we use absolute values to prove how far away it is from 0. In this case, 0 is in the center of negative 3 and 3. As you can see, both of them have a distance away from 0 of 3, no matter if it's negative or positive. So actually, in a sense, absolute values turn negative numbers into positive values. So this would be 3, and this is also 3. So if we would have, let's say, 2 minus 4, that would be absolute value of negative 2, which is 2 as a distance. So now let's take a look at actual problems. Let's say x minus 3 equals 10. So what we would do is solve for the positive value and the negative value. So let's say x minus 3 equals 10, that's positive, and the negative would be negative x minus 3, don't forget the parentheses, and we would solve them as a regular equation. So plus 3, x equals 13, and on this side, negative x plus 3 equals 10, negative x equals 7, and x equals negative 7 down there. Alright, so the next thing we're going to cover is basic graphing of absolute value equations, and here's the graph. So here's our basic parent function, y equals absolute value of x, and let's set up a little table. What we're going to do is plug in x, and 1 equals 1, 2 equals 2, 3 equals 3. And you get the idea, it's just the same thing for each. So the graph would look like this the whole time, and the absolute value equation has an iconic V-shaped looking graph. Right here the graph is a V-shape, and it will always look like a V-shape. If it's not a V-shape, you did something wrong. Here's our vertex, 0, 0, and that's our parent graph. Now, let's say we have y equals x plus 2. What would happen? So the 2 actually shifts everything to the left, to the right, and what it does, all the points would just be the same thing, but 2 points up. So that's what this would look like, just up by 2 units. And one more, so y equals x plus 2. Notice the important difference here is that this time the 2 is inside the absolute value compared to outside. And the difference here is that when it's inside, it goes through the x value instead of the y value. So instead of moving to the up or down, it moves to the left or the right. And if it is positive, it'll move to the right, to the left, because it goes the opposite side of what it says. Because if we actually write it out, so if we have x equals 1, y equals 1 plus 2, which is y equals 3. That point would be right here at right there. And what it looks like is that the graph will end up looking like this. So it just moves to the left by 2. So let's note some key features here. When it's y equals x plus number, that makes it move to the up or down. When y equals x plus number here, that makes it move left or right. And remember, it's opposite from the sign, so if it's positive, it'll move to the left. Thank you for watching. This has been SATFreePractice.com.